Saxon Algebra 1, lesson 120. Here we go. This is it. A box and whisker plot is a statistical measure Remember, statistics is the branch of mathematics that has to do with organizing data. That's what statistics are good for. They take lots of information and net them down into just a few key numbers that help us gain understanding over the whole body of numbers. This first example is going to summarize information about the salaries of mathematics textbook editors. Okay, just so you get the little pun, textbook editors are the people who write textbooks, right? They get them in order and they aren't necessarily creating the content because it's already known, but they're organizing the information into a book and they're writing all the examples and the problems and they're getting a book ready to be printed, right? So the editors of this math book decided to make a little wacky joke in the last lesson and write a problem about themselves, right? Because the people writing the problem are the mathematics textbook editors. So, cute. These are their salaries. They're paid incredibly poorly by today's standards, but that's okay. That doesn't affect the problem. What I want to do is I want to show you the end result of this box and whisker plot so that we can understand what the heck we're doing. And then later, after I show you what it looks like, we will figure out how to make it. Okay. 10, 20, 30, 40. This represents the amount of their salary times 1,000. Whoops. Amount of salary times 1,000. So this represents $10,000, $20,000, $30,000, $40,000. Okay? And then I'm going to put in 15, 25, and 35 just to help with our scale. I'm putting a dot above about where 26 would be. I'm putting another dot above 30, and I'm putting another dot above 22, so about there. Okay, so these are 3 dots I want you to put in. We're going to add the numbers in a minute. 22, 26, and 30. Put dots in each of those. Now put a dot at 18, which is down about here, and a dot at 35. Okay, now I've already drawn this line through here. Draw another line. Notice there are 5 dots. We're drawing lines through the second, third, and fourth dots. Now we're going to connect them like so. And then, see where there's the first and the fifth dot that we haven't touched yet? We're just going to draw a line connecting them. All right? Now I'm going to put in the numbers that each of these dots represent. This one is 18, this one is 22, this one is 26, this one is 30. We can see that one there, but these are important numbers. 35, okay. This is the least, this is the greatest. Then these 3 numbers here, I'm going to circle them just so that it's easier to see them. Then these 3 numbers all have meaning too. This is what we call the first quartile. This is called the third quartile. Don't worry, this will all make sense in a minute. I'll explain to you. And this one is called the median. We can abbreviate these as first quartile, second quartile, third quartile, all right? This is what this means. Of these 12 mathematics textbook editors that are part of the statistical study, it's quite a small one, but that's because we have to manage all this data by hand. We have drawn a graph that summarizes what we've learned about their salaries so that we can glance at it and get a pretty good idea. What we learned is that the median salary is $26,000. That's the halfway point. Half of the editors earned less than that. Half of the editors learned more than that. So that's what median means. Now, the very lowest salary was $18,000. The very highest salary was $35,000. Okay, so we plotted the least and the greatest and the median. Those are all numbers we're familiar with. Now, that means half the textbook editors were here, between the lowest and the middle. And what we did was we found the median of just this group too. Okay, so we took just this group. If there were 12 in all, then we took these 6 and we found the median of them, half and half. That number happened to be 22. So that's why we call it the first quarter, because it's the first quarter of editors in this range, the second quarter of editors in this range, and then we did the same thing over here. We plotted the greatest. We know this was the higher half, and then we found the median where 6 had more than this amount and 6 had less than this amount. No, we're at 3 and 3, aren't we? Because it's 12 in all. So halfway is 6. So there are 3 editors in each quarter. So this is where we calculated the third quartile. This is the median of the top half. And then we plotted it all using boxes to help us see the middle 2 quartiles. And then these lines, which we call whiskers, to help us imagine the extremes. Calculating this is pretty straightforward, but it helps if we see what we're trying to do before we start the calculations. Basically, we're just going to arrange our data in order so we can see the least and the greatest, and then we're going to find the median, and then we're going to find the median of the first half and the median of the second half and plot it all. Ready? Let's do it. So we'll come back to this picture. Let me rip it out so it's handy. I'm so into this. I changed my strategies. I used to leave all of my class notes in not three ring binders, in spiral notebooks, but now I rip them out and I put them in the binders, and it helps me flip back and forth and show you different things much more easily. I'm a fan. Okay, so we're still talking about our textbook editors, and John shows us right here their salaries, again, in thousands of dollars. So 25,000, 23,000, that's the actual number. It's ridiculously low for where we are now. When I graduated from college in 1980, and I got an excellent job in downtown Chicago, professional, the best job, my dream job, my salary was $18,500. That's not very much money, is it? But in those days, that was a professional wage. So times have changed, right? So these numbers look ridiculous to us. Look, there's somebody who earned the same amount as me. So anyway, don't let that throw you off. They're just nice numbers that we can organize. The first thing we do is we put the numbers in order from least to greatest. Okay? Now, I'm not going to waste our time showing you the wrong numbers. So the first step is put the data in order. And I'm going to call it data instead of numbers because it's a shorter word to write. So John's done the heavy lifting for us. And I'm going to do something that's going to be helpful to us. There are 12 in all. I've written 6 in the first row. And then I'm going to start the second row just going on from 25. It's 27. My biggest tip to you in this is make sure you put enough spaces between the numbers so you can easily read them. This got a little crowded. I don't really like how that looks. This is much better up here. Okay, so do yourself a favor. Now, I've already divided the numbers in half, haven't I? So I'm making it easy on myself. So we want to identify the least number. It's 18. The greatest number, 35. And the median. The median, just like the grassy strip in between the two sets of lanes on a highway, is the middle. Now, the way I've written this, I've set it up perfectly because I've got the first 6 and the second 6. The median on an odd number of data is the middle number. But we don't have a middle number because we have an even number of data. So we have to take an average. In this case, it's of the 6th and the 7th. Right? Because these two are the closest thing we have to a middle, but we don't have an exact middle. So I'm going to average those. And it's not going to be very hard. 25 plus 27 divided by 2. That's how you find an average, right? Well, I don't even have to do that because I know 26 is the number in between them. Okay, so we've got the median. We've got the least and the greatest. Now we need the median of the first numbers and the median of the second numbers. So that's going to be the first quartile the number we're going to use as our first quartile is just the median of the first half. So we look at our first set of data and go, okay, we still have an even number of data, so we don't have a quote-unquote middle number. So now I have to average 21 and 23. And again, that's super easy. I know it's 22. I'm going to squiggle these numbers because we need them. And then I'm going to need to find the third quartile, which is the median of the second half. So now I can just look at my second row of data. See how when I wrote it out, I was doing myself a favor? So, 2 rows are nice. Make sure they're perfectly even rows, but that really helps us manage this data easily. So now I want to have the median of the second half. Let's see, where's my... Here. I want to cover up my top row so I don't look at it. Okay, so when I go to find the median of the second half of data, I just look at the second row. These are the closest to the middle. Again, I have that even number of data points, so that means I have to do my little calculation. If I had an odd number, if I only had those, then I would just pick the one in the middle. 29 plus 31, again, that's not much of a calculation because I can tell just by looking at it, it's going to be 30. Now I've got all the information I need, and I am ready to draw my picture. And spoilers, we know what it looks like because we've already drawn it, right? But let's go ahead and pretend that we haven't. Right, so we draw our number line. We know it needs to go, let's see, I have to go as low as 18 and as high as 35. So I'm gonna do 10, 20, 30, 40. You get to set your own number line, so you get to figure out roughly what numbers you want to show. Okay. Now I start dotting in my points. We start with the least and the greatest. The least is 18. I'm not going to write the numbers yet. I'm going to draw the picture first. The greatest is 35. Okay, so I'm putting dots for all of these. The median is 26. So I go up from that. Then my first quartile is 22. So that's about there. And my third quartile is 30. So I use the middle 3 points. Last time I drew those 3 first. That was helpful. But I draw boxes that wrap up the middle 3 points, and then I draw the whiskers going out to the extremes. Okay? I'm going to put the values of the points. I'm going to write them above this time so I have a little bit more room. And I'm referring back to this page, right? Because I have all this information. Let me just squiggle these. My least point is 18. My greatest point is 35. So I'm going to write least. And I'm going to write greatest. My median is 26. My first quartile is 22. And my third quartile right here is 30. And that's... Let's do arrows. And there it is. There's our box and whisker. And these days, these calculations would all be done on calculator. I mean, that's the story of math, right? Nobody's earning a 9 to 5 by sitting and cranking through these numbers. But this is a nice process for us to go through because it helps us see how these numbers, so we can see, oh, look, these 3 boxes look roughly the same size, so the results are spread fairly evenly. But when we get to the high end, that's kind of a stretch. There's more of a range in that one, right? It helps us visualize how these math textbook editors are being paid. Is there another one? Yes, there is. This is it, our last example of the year. I'm going to fall over. The box and whisker plot shown shows the scores made on the final exam by 150 students. All right. So I'm going to copy it here so we can talk about it. This goes from 0 to 100. Those are the scores you can get on a test, right? And so let's see, this would be 50. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's just me spitballing, trying to get this fairly even. Okay, so these are the different scores. And the box looks like this. The lowest whisker is at the halfway point there, because John goes and puts halfway points in between all of these. He doesn't label them with numbers, but he just draws them in. The first quartile box looks like it's about 74. This looks like it's about 55. I'm going to label them above. This looks like it's about 74. I'm copying this out of the book, as you know. The next point is right at 80. The next point is at 95. And the final point is 100. Okay? The box looks like this. Now this box is a little different than the box we drew last time, isn't it? Because look at how this one's small and this one's big. That tells us that in these students, let's look at the whole thing. There's, in the first quartile, the lowest 25%, of the students, there's a fairly broad range. Then it was really tight here between 74 and 80. There's a pretty tight grouping. Then it goes big again, and then it goes fairly tight again. So we see that the scores tended to be concentrated here and here. The smaller the box or the whisker, the more concentrated the scores are. Okay, so what we're supposed to do is find A, the range, median, mode, and mean. Range. Okay, what is the range? The range equals, I always think of it this way, the high minus the low, and that is 100. Minus, there's our low score, 55. So the range is what, 65? No, 45. And that's super easy to see because we can see, oh look, all the picture falls between 100 and 55. So that means it's covering 45 different percentage values. Okay, the median. The median equals the middle. And we can see that easily because, as we know, the median is the dot in the middle of the box. So our median score equals 80 in this picture. We don't have to calculate it. It's simply labeled, right? It's the middle of our chart. This is the low, this is the least. This is the greatest. This is the, sometimes I just like to write first quarter, second quarter, third quarter, and we know that second quarter is also the median. All right, here comes the trick. We're also asked to find the mode and the mean. The mode is the most popular score, one that has been achieved by multiple people. We don't see any individual scores. We can't calculate the mode. The mean is where we take all of the individual scores, add them up and divide by the total. We don't see any individual scores. So the mode and the mean cannot be calculated. Okay? So the box and whiskers plot does not allow us to calculate all of these, but some of them, yes. And the last step is we're supposed to describe what does John say? Describe the distribution of the scores. This is a weird answer. I don't like the way he answers it, and I don't think it's very meaningful. But what I would say is that this shows the 4 different quadrants, the 4 different groups that the students fell in, right? This is the lowest 25%. This is the next. This is like 25 to 50%, 50 to 75%, and then the top 25% here. Okay? That's not the scores that they got, but that's how many students there were. And as I pointed out before, the tighter, the shorter either the box or the line, the more concentrated the students are. So I would say there's a concentration of students who scored between 74 and 80, and another concentration of students that scored between 95 and 100. So, I mean, if you look at it that way, some of the kids are doing really well, and some of them are struggling, all right? Describing the data is the least important part of this work for us because we're not statisticians that are trained to interpret this. We're just trying to understand how these graphs are constructed. And that we do by putting in the lowest and the highest, the median, and then we find the median of the first half and the median of the second half. That's all there is to it. Box and whisker, because it doesn't look like boxes and then whiskers. I always think this looks like a cat's nose, but it only has one whisker. I don't know about any cats you've seen, but my cats have many whiskers, and they're all long, so there's that. Guess what? Make sure you write this in your notes. This is the end of Algebra 1. I get a little emotional every time I come to the end. It's such a journey, and I was thrilled to take it with you. I hope you will be back to take Algebra 2 with me whenever your studies lead you in that direction. And it has been a joy. If you are a local student and you're taking the final exam with me, remember it's just like all of our others. It's not really a final, it's just another midterm. 10 questions, 5 points each, taken from the most recent material. On Monday, I will drop a video telling you exactly what to study, and then I will drop the test by your house Wednesday, midday, and then I'll be back in the middle of the afternoon on Thursday to pick it up. I'll get you your score. We'll be done. We'll all be thrilled. All right? Thank you very much. It has been a pleasure. Goodbye.